sklearnmetricscheckscoring. Description. The check scoring function in scikit-learn sklearn is a utility function that ensures the scoring parameter used in various model evaluation functions is valid. It helps in standardizing the way scoring metrics are handled, preventing errors and ensuring consistent behavior across different functions. Inputs. Scoring. This input is a string, callable, or dictionary-like object defining the scoring metric to be used. It can be a predefined scoring metric name from scikit-learn like accuracy, recall, F1 score, a custom function, or a dictionary specifying different metrics for different output types. Estimator. This optional input is an estimator object, e.g., a classification or regression model used to determine if the provided scoring metric is applicable to the estimator's task classification. Regression, etc. Outputs. Scoring function. This is the output of the check scoring function. It returns a callable object function that can be used directly to evaluate the performance of a model. This callable function is tailored to the provided scoring input and ensures its compatibility with the estimator if provided. Steps. Validation. The function first validates the provided scoring input. It checks if it's a valid string representing a predefined metric, a callable function, or a dictionary specifying multiple metrics. Function conversion. If a string representing a predefined metric is provided, the function converts it into a callable function that can be used for scoring. Estimator check. If an estimator is provided, the function checks if the scoring metric is suitable for the estimator's task, e.g., if it's a classification model, it checks for metrics appropriate for classification. Metrics. Accuracy measures the proportion of correctly classified instances in a classification task. Precision measures the proportion of correctly predicted positive instances among all instances predicted as positive. Recall. Sensitivity measures the proportion of correctly predicted positive instances among all actual positive instances. F1 score. A harmonic mean of precision and recall, providing a balanced measure of both. AUC area under the receiver operating characteristic curve measures the overall performance of a binary classifier, summarizing its ability to distinguish between classes. R2 coefficient of determination measures the proportion of variance explained by the model in a regression task, indicating the model's predictive power. Mean squared error MSE measures the average squared difference between predicted and actual values in a regression task. Root mean squared error RMSE the square root of the MSE, providing a metric in the same units as the target variable. Mean absolute error MA measures the average absolute difference between predicted and actual values, providing a more robust metric compared to MSE. Visualization plots. Confusion matrix. A table that visualizes the performance of a classification model by showing the counts of correctly and incorrectly classified instances for each class. Receiver operating characteristic ROC curve. A plot that shows the trade-off between the true positive rate and the false positive rate for different classification thresholds. Precision recall curve. A plot that shows the trade-off between precision and recall for different classification thresholds. Residual plots in regression tasks. Plots that visualize the difference between predicted and actual values, helping to identify patterns and assess model fit. Fine-tune parameters. None. The check scoring function does not have parameters to fine-tune. Uncertainty methods. Confidence intervals. Estimating confidence intervals around the calculated performance metrics can provide an idea of the uncertainty associated with the model's evaluation. Bootstrap resampling, repeating the model training and evaluation process multiple times using different random subsets of the data can provide a distribution of performance metrics, giving an indication of uncertainty. Challenges and fixes. Challenge 1: incorrectly specifying the scoring metric. Sample use case: providing a scoring metric name that doesn't exist in scikit-learn, or using a custom function that doesn't return a valid score. Fixes: double-check the spelling and validity of the metric name. Ensure that the custom function returns a scalar value that represents the model's performance. Challenge 2: using a scoring metric inappropriate for the task. Sample use case: trying to use an accuracy metric for a regression task or a classification metric for an unsupervised learning problem. Fixes: ensure that the selected metric is appropriate for the task classification. Regression, clustering, etc. Use appropriate metrics designed for each task. Challenge 3: incompatible scoring metrics with the chosen estimator. Sample use case: attempting to use a scoring metric not supported by the estimator, such as using an AUC score for a multi-class classification problem. Fixes: refer to the documentation of the specific estimator to verify the supported scoring metrics. Choose metrics that are compatible with the estimator's functionality.